problems, let's take a look at the actual representation of the results. So my goal here is not for you to get to the point where you understand all of that that's happening right now. That will come in 5 minutes or so. Right now, I just want you to understand that the thing on the left side here is usually given. So that is the problem statement. And your final result is what you see here on the right side. So this is the proper representation of the final result. So solve for final representation. So let's look at what's part of the final representation. So the first thing we observe is that we have this triangular assembled structure here, and we have a roller at A and a pin at C. And if you take a look at the picture on the right side, you see that those external forces are shown as external forces. Right? So they are given here with the right values already. It's already been solved for you. And the problem here is not about numerical values here. We will do that in just a second. Right now, we just want to understand how we show our results. So let's take a look at, for example, node A. So if I take a look at node A, I can effectively release it, right, by cutting this node. And when I do that, I actually end up with this part. And what you see is that the 600 is actually pushing on the node. So that would actually put it in compression, but it's a support reaction, so we don't worry about this. But the 450 here is pulling away from the node. And so this is a tensile force. The 750 is pushing on the node A, and therefore it's a compressive force. And if you already pay close attention to what happens on the other side of this cut here, you see that the tension is already given here and the compression is given here. So now we can follow our logic and actually look on the other end of the node. So for example, let's take a look at node D. So I release that node here. And what we observe is that the 450 Newton that we calculated maybe here also must be acting here at node D, right? And now comes the last part in which I have to release the inner component. So that is the actual member. So we have the node on the outside. So here I have node A, here I have node D, and the actual member on the inside. And often students struggle with understanding in which direction these arrows have to point, but let's look at it. So if you have the tension on the node here with 450, then here you have to, of course, also pull away with 450. So this member here is in tension, and this node is in tension, and this node is in tension. So don't get confused by the direction of the arrow in like the global sense. Just look at the local components. So the node here in tension, the member in tension. Node in tension, member in tension. And you can use that to move your way around. So like the things you have to identify is it pulling away from the node or is it pushing on the node? And if it's pushing on the node, it's a compression member. So I have to show that. If it's pulling, it's a tension member. I have to show that. And then I also have to include the numerical results. Sometimes you would actually see it only given once. So for example, here the compression member would have 750 there. And then sometimes people write it as compression. And then here 450, and people would write it in tension. That's another way of showing that. But in a bigger picture sense, the goal for you is to draw this picture at the very end to show how the forces act in each member and to identify clearly if it's in compression or in tension. And if it's an external force, either an external force acting on the system or a support reaction, that must be included in the system.